Hello everyone, welcome to this class. This class I'm going to deal with equal intercepts. When you have a line AB, another line CD, and a line transverse through the line, let's call the line PQ. The point which the line passes through the line is called the intercept. Let's call this XY is the intercept. You see the point at which it's transverse through the line is called the intercept. We're not talking about this ones out. That leads us to theorem 8. Theorem 8 says if 3 or more parallel lines cut off equal intercepts on a transversal, then they cut off equal intercept on any other transversal. What's the law trying to say? It's saying that if you have something like this, and this is a parallel line, because we are dealing with 3 or more, because when you, let me say, we have two parallel lines cutting through a intercept. We're not talking about, let's say we are referring to this and this. No, we're not talking about that. We're really referring to 3 or more. So let's say this 3 parallel line, and you have a line passing through it like this. This is the first transversal. So what you're trying to say, even if you have another line like this, you have another line like this, what they're trying to say is that if you are able to confirm that this place to this place is equal to this place to this place, so you can be rest assured that here to here is also equal to here to here, and the same thing here to here is equal to here to here. You don't, irrespective of how the transversal looks. You can say this one is going like this, that one is going like down, that one is still going up, irrespective of how, even if it's going straight, so long as you can confirm that this 3 parallel line or more, it mustn't be 3, but 3 is the minimum, transverse was able to divide this intercept here. You know what we said is intercept. Look at the intercept, the portion of the line that is being cut by the parallel line. If this is equal to this, then you can be sure that this is also equal to this, that is equal to that. So let's prove that in the next. So remember what I was saying in the other slide. Look at here, when I was talking about here, it must be 3 or more. You can't just say 2 parallel lines. Let me say you have 2 parallel lines and you're not trying to say that, oh, this is equal to this. No, it's from 3 lines up. So let's prove this theorem. I have this parallel line 1, 2, and 3, and then I now have a transversal. I have this transversal. Let me call this first transversal here A, B, and C, and call this one X, Y, Z. So I have this transversal. So the idea of this class is to, already I'm saying that this A to B is equal to B to C. So now I've said that they are equal. I'm trying to prove that, okay, this other transversal, that XY will also be equal to what? YZ. Are we together? So this is what we are trying to prove. The diagram we are given, AB is equal to BC. This one we are given, that I wrote given. Now we are to prove that XY is equal to YZ. First thing I'm going to do is I'll draw a parallel line here, a line that is parallel to AB. So I'm using double stroke because we already use single stroke for this other parallel line. So we'll now use double stroke for this one. I'll now draw another one again. Let me call here P. Let me call this line XP. So I'll draw another one again. I'll call this one Q. Using double stroke too. So here too. So what I'm trying to say is that AB is parallel to XP and BC is parallel to YQ. So if this is a line I drew by myself and I make sure that I drew it to be parallel. So remember the previous class we did that for a parallelogram, the opposite sides are equal. So if I'm to do that, I can comfortably say that for AXPP, so I have AXPB as a parallelogram. So from there, our now call is a parallelogram. So from there, I can comfortably say that AB is equal to what? XP. So AB equal to XP. Reason being that it is an opposite side of a parallelogram. So for those that are wondering what happened here, the previous class, check this list. You on the parallelogram, you will see where we explained all these parallelograms law. So at the same time, I have another parallelogram to deal with. I have this BC. No, sorry, it's supposed to be B. Okay, let me go this direction, but it's supposed to be BYQC. That's BYQC. Is also a parallelogram. Let me just use this as the example, as a name. So from there, I can say that BC is equal to YQ. So BC is equal to what? YQ. The same reason, opposite side of a parallelogram. Are we together? So we're able to prove that this is equal to this and that is equal to that using the parallelograms law. So the first thing we have to see that you already know that if this is equal to this, if AB is equal to XP and BC is equal to YQ, we already know that AB and BC are equal. So from there, I can comfortably say that XP is equal to what? YQ. So since AB is equal to BC, you understand? Therefore, XP is equal to what? YQ. That's very, very clear. Since this is equal to this and this is equal to that, so this is also equal to this. These two are equal. Not mind my mistake here. So the next thing we are now going to do is, let's consider this triangle, these triangles XPY and triangle YQZ. Understand? So let me create an angle here and call that angle X1. Create another one here and call it Y1. I create another one X2 and Y2. Are we together? So we are now considering triangle XPY and triangle YQZ. Now we are able to confirm that here and here are equal from here. So we are trying to know if these two triangles are congruent. So we know that XP is equal to YQ. That's already certain. So the first thing we are now to check is these two angles here. What do you observe? These two angles. What do you observe? That's the next thing we are going to check. You observe that this is a parallel line and this is also a parallel line, and a transversal now cut through the parallel line to create Y1 and Y2. And according to our geometry, this is what we call corresponding angles. When this is a parallel line and the transversal transverse them, any angles that are in the same position, you understand, this is the same position as this, call them corresponding angles. From there we can say that Y1 is equal to Y2. Reason being that it is a corresponding angle. So go for X1. Now for this X1, you notice this is a parallel line and this is another parallel line and the line transverse. So here and here are also another corresponding angle. You see, it is in the same position. Let me explain this corresponding angle. You have a parallel line like this, a line pass like this, you can see that this angle here and this angle are corresponding because this is a parallel line. A line does pass through it, and this is another parallel line. So you see that both of them are in the same position, and according to our geometry, corresponding angles are equal. But this one here, that is like Z shape, is called alternate angles. Those ones are equal, but this is not what we are trying. We are more focusing on the corresponding angle part. So since this is a two parallel line, and it occurs for two parallel lines or more. So these two parallel lines and this line transverse. So x1 and x2 are corresponding to each other. So you can say x1 and x2. S1 is equal to x2, reason being that it is also corresponding angle 2. Are we together? So from here now, we already satisfied that triangle XPY is congruent to triangle YQZ, and the criteria for the congruency is what we call AES. For our theory on congruent triangle, check this list. You see the topic congruent triangle in the list. You will find it here. So A means two angles equal and one side equal. So we were able to confirm that x1 is equal to x2 and y1 is equal to y2. That's angle x1 and angle y1. So, and we already able to prove that these two sides are equal from here. So it means that these two triangles are congruent. And when you have confirmed that the two triangles are congruent, the corresponding sides becomes equal automatically. And what are the corresponding sides here? XY and YZ. These are the corresponding sides. So x1 will now be equal to YZ. So you now say XY. Or I say therefore, because this can only be possible because these two triangles are congruent. I can't just say like the way I have this line like this now. Let me say this is a third parallel line. You now say, oh, because these are obviously they are corresponding sides, but you can't confirm if they are equal yet. So I was able to say, oh, this XY is equal to YZ because XY and YZ form a triangle that are congruent. So therefore, XY is equal to YZ. I think this is what we want to prove, that XY is equal to YZ. That proves what we want to prove in this class. So let's solve example relating to this equal intercept. Now we go to exercise. We go to exercise 2F, number 1. You see how simple it is. What does equal intercept mean? It just, once you can confirm that A is a parallel line, 1, 2, 3, we are even told. Once we can confirm that, okay, the intercepts of this parallel line in one transversal are equal, you don't need any other thing. Whenever you see another transversal again, just know that the intercepts of those ones are also equal. So yeah, we are giving the sign of equality. This is what we need to indicate equality sign. This one is to indicate parallel lines. So obviously, what this transversal already, these three parallel lines, call them equally. So this is another transversal. We already know that this K, because look at what we have been to find the lettered length KMN meaning TOZ. You know, A B C D F G K L L K M N O and the rest CO what? Z. So any alphabet we are given, we should find the length, and we have been told that in figure 2.4, all these are figure 2.4, all these you are seeing, dimensions are in cm. So from here, K will obviously be equal to what? 3. So K is 3.1 cm. We don't even need to solve anything. Very straightforward. So B part. Mind you, before you apply this equal intercept theorem, you must be told. Like here, we are told that these are equal intercepts, but here we are not told. So we have to apply logic. We have 4 parallel lines, 1, 2, 3, 4, and we have an intercept here and another intercept here. So what we need to do is to prove that, okay, if this is equal to this, it also means that this to this is equal to that. Now we are being told now for this particular one with the value. So since 3 is equal to 3, we already know that this m will also be equal to this using our equal intercept theory. So m will be equal to 2.5 cm. Now we now come to this n. We've already found m, so we can now you see I started with the one that have only one unknown before I now move to the one that have, because I've gotten this now, it's almost like we're dealing with just one. Let me put this on here, 2.5. So here now, solving for this, we now check out for this diagram here. So since this is equal to this, so equal intercept theorem now applies. So in that, from there now I can say, okay, n is equal to 3. N is equal to 3 cm. Some people will just see this thing and say, oh, because it's moving like this, here will be 3, here will be 2. Yes, they will get it, no doubt. But the question is, you must be sure, you must be told. Don't just assume because of the diagram is looking equal. You understand? The examiner might confuse you and do some twist. You understand? Sometimes you will be wrong. While you're wrong, your analysis will be wrong, but you're getting the right answer. As the saying always goes, that even a stopped clock is right twice in a day. So let's go to the next example. Here we are given this equal intercept here already. So we have to use it to solve for this p. So from here, since these are an equal intercept, we already know that p will be equal to 7. So p is equal to 7 cm. That's when you can now come up to this q side. Since here is 7, now p is 7, I'll replace it with 7. It is already another equal intercept. Therefore, q also will be equal to 8 cm. Let's go to the next example. We have here, these are parallel lines. And mind you, I think I'm missing something. I missed something in the last example. I forgot to say that it was a parallel line. 1, 2, 3. For that reason, that's why this equal intercept theorem can work. So let's go to the next one. This is a parallel line. See, we are indicated with this arrow sign. And we are told that these intercepts here are equally divided. For that reason, any intercept will all be equally divided. We have been told. So r will be equal to 5.2 cm. You know why I'm adding cm? Because of the, in the question, we have been told that all dimensions are in cm. Forgetting the fact that they are not putting it in the question. Your answer is supposed to come with it. Very important. So now I've gotten that my r is 5.2 cm, and to look for s, right? Still equal intercept. This intercept still apply. Remember what I told you. Once you can confirm that an intercept was transverse equally, no matter how the shape, like now this one is almost like that one is, it doesn't mean anything. Just apply the theory, you still get it. S will be equal to what? 4 cm, because s will be equal to this. Now let's go to this part. Here we have been told that this transversal was equally divided. So for that reason, the equal intercept theory we apply here and also apply here. But now we have been told, let me look for t. T will be equal to what? 2.5, because the equal intercept theory we apply 2.5 cm. V will be equal to 2.5 cm. Then u, there's a little trick here. Now you can see that u has to do with this parallelogram, this parallel line and that parallel line, meaning that we have to, it's like 2 times of this 3 here, because it's supposed to be 3. The purpose is not, if you instead this one, it will still cut it to a place that you have something here will be equal to 3, and here 2 will also be equal to 3. So u will be equal to 3 times 2, which is 6 cm. I hope you're making sense. So let's solve the final one. Now we are, in this case, we are given 2 parallel lines, but we are not given anything to tell us that this is an equal intercept. So here now we have to apply our own logic to it. That's why I say, if it is not indicated, don't assume. Some people will say, oh, since this is like this, because you are solving equal intercept, they will not say the x is 5. You know, start making some mistake. You might get it, but we're talking about the logic behind your answer should also be correct. So now we are not giving. So let's apply another law. Which other law we're going to apply? Let's consider this. This is a parallelogram. And according to parallelogram, the opposite sides and the opposite angles must be equal. Sorry, the opposite sides are equal. So this side is opposite to this side, right? Why do I call this a parallelogram? Because from the indication, look at it, it was indicated that this is parallel to that. So whenever they connect, it will form a quadrilateral, we call it parallelogram. We treated this in this list. Check this list of this class. The topic, the one that has the title parallelogram, you see the answer there. You see the explanation. So from there, you already know that 8 is equal to, because 8 and y are equal. So you can see y is equal to 8 cm. So I'll replace it with 8 cm. Also, look at this square here, or let me say this quadrilateral here is also another parallelogram. Are we together? How? Because we are told that these are parallel lines. So, and according to the law of parallelogram, two opposite sides are equal. So from there you can know that z is equal to 8. So z is equal to 8 cm. Here is another opposite side of this parallelogram. So w will be equal to what? 6 cm. So w is equal to 6. I don't necessarily need to put the cm there. Okay. So what else again have we not found? We need to find this x. As you can see, I made a mistake in this my diagram. There is 6 here, because I was wondering how am I going to deal with this. So I've confirmed there is 6 here. So now that I've confirmed that here is 6, and we're able to find our w to be 6. From that case, we already know that this intercept is also equal to this intercept. You can see. For that reason, any other intercept will be equal. You see, this 6 here will also be 6. And for this intercept, we'll apply the equal intercept theorem. Since here is 5, here will now be 5. X will be equal to 5, because we're now applying equal intercept. That since these are equal intercepts, any other transversal, this is another transversal on its own, so here will be 5. So x is equal to 5 cm. You see the way I did not assume. I know if you have assumed, you still get here 5. You still, those that were assumed, since here is 6, which I omitted earlier, you still get here 6 and all that. But no, try to get the logic behind the question. So let's go to the next example. Exercise 2F number 3. Use the figure 2.43, this figure 2.43, to answer the following. What is the ratio of xp and xy? Where is xp? This is xp and this is xy. We can't say that now because we don't know the value from the question. Number B, what is the ratio of zq plus q and qx? This is zq and qx. Okay. Then number 3, if xp is equal to 9 cm, now we start getting value. Xp here is 9 cm. I'll just put 9. Let's leave the cm. What is xy? What is xy? Now, look at this. We are told that this is equal to this, equal to this, equal to this, equal to this, and look at this is a type parallel line, parallel line, parallel line, parallel line, parallel line. So we can apply our equal intercept theorem, and this is a transversal. So this parallel line, these ones that we have double stroke, is like when this is a parallel line, and this is a transversal, and we are equally divided. So for that reason, this another transversal we are dealing with will also be what? Equally divided. So if here is 9, it means that here too will be 9, here will be 9, here will be 9, and here will be 9. So we are being told that if xp is 9 cm, what is xy? So xy will be this 9 here, 1, 2, 3, 4, 5. So xy is 9 times 5, which is 45 cm. So the next question is, if ZQ is 3.5 cm, what is QZ? So what is ZQ? This is 3.5 cm. What is QX? So using our equal intercept theorem, here will also be 3.5, 3.5, 3.5, and 3.5. So we have been told to look for QX. So it simply means 1, 2, 3, 4. So QX, I forgot to put the magnitude side, is 3.5 times 4, which is what? 14 cm. Are we together? So from here now we can now do the ratio. We have been told xp is 9. It will be 9 all over yp, and xy 45, which is what? 1 over 5. The second one, ZQ is 3.5 all over QX is 14. This will give us what? 1 over 4. I think this summarizes our class on equal intercept.